Hi friends, let us first understand the Himalayan mountain system. Let us go in the terms of physiography by first studying the Himalayas, then the Great Plains, then the Peninsular Plateau, and then some of the applied aspects. Now before understanding the Himalayas, before studying the Himalayas, let us revise. I am using the word revise, the origin of the Himalayas. Why using the word revise? Because I have already taken the origin of the Himalayas in your plate tectonics animation lecture which I took as a part of an animation slide, that is your fourth lecture, which explains everything about the plate tectonics. In the later part of that lecture, I have explained you the formation of the Himalayas. So again we will revise how did the Himalayas form on the whiteboard here, while on the digital board I have explained you in that lecture. So you can just revise that lecture, the later part of the lecture of the plate tectonics, to understand the origin of the Himalayas. That lecture is very long, something around 1 hour 40 minutes lecture, but it explains you the very basics of the geography. It explains you the very basics of the formation of the Himalayas. So you look at the later part, but let us revise how did the Himalayas form. Now before understanding the Himalayas, how did the Himalayas form, let me quickly revise what is the Himalayas. The Himalayas are the young fold mountains. Why young fold mountains? Because they are formed in the recent period in the geological history of the earth. Not the recent period in our history, not last 20-30 years, but something around 20 to 30 million years ago. That is what is the geological history of the earth. We always talk in the terms of million years ago. So the Himalayas origined because of it can be explained by the two theories. That is, one is geosyncline theory and other is a plate tectonics theory. I will explain you the combined effect of both. How did the Himalayas come? And this is what you have to write in your answer also. That is, explain the origin of the Himalayas. The Himalayas came due to the coming together or due to the convergence and resultant collision of the two plates. That is, one is the Indian plate and the other is an Asian plate. The Indian plate was a part of what? The Indian plate was a part of a Gondwana land. So you know that this Indian plate was a part of a Gondwana land, while the Asian plate was a part of a Laurasia or Angara land. And the two plates were separated by a narrow, shallow sea, which was known as a Tethys Sea. So this Tethys Sea was a narrow, shallow sea. It was a narrow, shallow sea which separated the Indian plate from the Eurasian plate, or which separated the Gondwana land from the Angara land. Such a narrow, shallow sea. Look into my words, understand my words, then you can jot down the lecture. Such a narrow, shallow sea is known as a geosyncline. I have not taken geosyncline because that is not required for your general studies point of view, but only thing is what is required is the definition of a geosyncline. So what is a geosyncline? Geosyncline is a narrow, shallow water body. Obviously sea is a water body which lies between the two rigid land masses. Obviously the land masses are rigid, but so the geosyncline, I will write here the definition of a geosyncline. The geosyncline can be defined as a narrow, shallow water body. As a narrow, shallow water body which lies between two rigid land masses. Which lies between the two rigid land masses. So this is known as a geosyncline, and one of the best example is a Tethys geosyncline, which was between the Indian plate and the Eurasian plate, or which was between the Indian plate and the Eurasian plate. So this is an Eurasian plate, this is an Asian plate, or we can we combinedly write it as a Eurasian plate, and this is an Indian plate. And as you can see in this diagram, Indian plate is moving northward, and this area where I have defined the geosyncline is a water body. So this is this is a narrow, shallow water body which is known as an geosyncline. The example is a Tethys geosyncline, and the best example is a Tethys geosyncline. Why best example? Because Himalayas are believed to come out of the Tethys geosyncline. That is why in the previous lecture I gave you an example of the mythology of a Samudra Manthan, in which the Meru Mandar mountain or the Meru mountain came out of a sea, came out of an ocean, and during the Samudra Manthan between the devils and the gods on the other side, on one side, and similarly here the Himalayas are believed to come out of the Tethys Sea or the Tethys geosyncline, which was between the Asian plate and the Indian plate. So this part where I have written the definition and marked it bluish in color, this is nothing but an Tethys geosyncline. Now as the Indian plate went towards the Eurasian plate, or as the Indian plate moved northwards towards the Asian plate, or we can say as the Indian plate went near the Asian plate, the Tethys geosyncline decreased in size. Inside this Tethys geosyncline, obviously these are the land masses, and therefore from this land masses rivers originated. From any landmass, river will originate and it will go into the sea. So even from the Tethys geosyncline, rivers originated and it went into the sea. And while going into the sea, large amount of sediments, which I am showing with the red dots now, got deposited in the Tethys Sea. As the sediment size increased, and as the Indian plate, which moved from this position to the north, and from this position further northward, the amount of sediments in the geosyncline also increased. So as a result, the depth of a Tethys Sea, because of a sedimentation, what it will be, increase or decrease? The depth of a Tethys Sea, if the sediments, that means if the broken rock materials are put into narrow, shallow water body, the depth of a sea will obviously decrease. If you don't remember the famous story during our childhood, that is the crow, a story of a thirsty crow. How the thirsty crow used to drop pebbles, how the thirsty crow dropped the pebbles inside the water vessel and increase the level of water, or we can say decrease the depth of a vessel. And therefore there was large amount of sedimentation in this Tethys geosyncline, and the sedimentation decreased the depth of this Tethys geosyncline. So this blue color water is now getting converted into red color water. Just imagine what I am doing here. Now as these plates came near each other, that means as the Indian plate came near each other, so what does the plate tectonics theory says? It is, one is geosyncline theory, I told you, that in between there was a Tethys Sea, there was a water body known as a Tethys Sea, it is known as a geosyncline. But these are examples of a two convergent plates. So mixture of both the theories we are doing, so that in the examination you will write the perfect answer and get good marks in the mains examination. So the Indian plate and the Asian plate were an example of a converging plate boundary. That is coming together of a converging plate boundary, and you know that in any converging plate boundary there is a high amount of folding because of large amount of compressive forces which are applied. So if this is a Tethys Sea and one is the Indian plate and the other is Eurasian plate, the coming together of Indian and Eurasian plate is folding this area in between, and the sediments in the Tethys Sea are folded to form the fold mountains. So not just one single fold mountain. As the folding keeps on continuing, we give rise to asymmetrical fold and then recumbent fold, and then again it keeps on, the process of folding goes on, and thus we have large amount of fold mountains which are formed. Even today the Indian plate is going below the Eurasian plate and thus folding the Himalayas. So what did I show with this? I showed that initially there was a Tethys geosyncline. This is an Eurasian plate. Imagine this, my right hand as a Indian plate, my left hand as a Eurasian plate. The Indian plate is pushing or going towards the Eurasian plate. As a result, the sediments in the Tethys Sea are getting folded. As the Indian plate is pushing, see, I am moving only one hand. There is a resulting formation of a fold mountains of the Himalayas. As the process of Indian plate still goes, the mountains are getting folded, and thus there is a formation of again a folding. Intense folding gives rise to formation of an very high mountains. And now the Indian plate is going below the Eurasian plate. So what happened is, as the Indian plate moved northwards, the sediments in the Tethys Sea got folded, and when the Indian plate collided with the Eurasian plate, so I will rub this, when the Indian plate collided with the Eurasian plate, as a result the sediments in the Tethys Sea got folded. The sediments from both the plates got folded to give rise to very high mountains here, which are known as a Himalayan mountains. So give rise to very high mountains which are known as an Himalayan mountains. Now because the folding here, I will use both the colors to show you that both red color, that is sediments from the land, as well as the sediments from the sea are there in the Himalayas. So as the sediments got folded, this gave rise to one of the biggest mountain system in the world, which are known as an Himalayan mountain system. So this combination of both these colors show that there are some of the marine deposits in the Himalayan mountain system. There are some of the marine deposits in the Himalayan mountain system. Now this is what is the side view, while the top view will look like this. Initially the Himalayan mountain system came and collided with the Eurasian plate. So there was first the Aravalis, the western part of the Indian plate came and pushed the Eurasian plate, and as a result there was this bending of the Himalayas. Then after collision there was some kind of a rebound, and therefore later on the western part, the eastern part of the Indian plate came and collided with the Eurasian plate, and thus there was a collision which looked somewhat like this. Because the Indian plate had two extending arms, you can see there were two extending arms. One arm is this, shown by the Aravali mountain system. The other arm is this, and beech mein the Indian plate is in the middle, it is sagging down. Similarly, therefore, the collision also occurred, resulting into formation of a hairpin bend like in the Himalayas, then sagging down of the Himalayas, and then again the hairpin bend in the Himalayas. As a result, what we have, the Himalayas are convex to the south. South means this is the equator, and we are just lying somewhere to the equator. So this is the north, this is the southern hemisphere, and Himalayas are the convex to the south, and we represent Himalayas as the hairpin bends. So we have two hairpin bends in the Himalayas, shown by Nanga Parbat mountain in the west and Namcha Barwa in the east. So there are two hairpin bends in the Himalayas. Why the hairpin bends in the Himalayas are? This is because the arms of the peninsula, that is the Aravali range and the Assam Himalayas functioned as two arms which gave maximum push to the Asian plate, and as a result the hairpin bend in the Himalayas were formed. So what we can conclude from this, that is we can conclude two things from here. The Himalayas, now I will rub this diagram here because I will use the board to write. Again, before that, repeating, Indian plate was a part of Gondwana land in the southern hemisphere. It started moving towards the Eurasian plate. As a result, the Tethys Sea in between got folded to form the Himalayas. How are the Himalayas? The Himalayas are the series of three parallel mountains. Why? Because the collision occurred during three times. As the Indian plate came and first pushed the western part, therefore initially western Himalayas were formed and later on the eastern Himalayas were formed. That means you are getting one preliminary question here is, are the western Himalayas older than the eastern Himalayas? Yes, because pehle this, then it went up, then first this part of the Himalaya got collided, and after that the eastern part of the Himalaya got collided. Because you see how the direction is not straight, direction is somewhat more, we can say it is more towards the north on the western side. So first the western part of the Himalaya got folded. Why the Himalayas have syntaxial bend, or why the Himalayas, we always show that they have a U-turn like bend or a hairpin bend at this two part. This is one part jahan pe hairpin bend is there. This is the other part jahan pe the hairpin bend is there. This hairpin bend in the Himalayas are because of the maximum push offered by the peninsular plateau through its arms. One arm is Aravallis and the second arm is the Assam Himalayas or Assam Hills, or these two arms of the peninsular plateau, and therefore because the maximum push was offered by the peninsular plateau at the two extremities, and therefore the Himalayas are is having a hairpin bend. Hairpin bend means, how is hairpin? The hairpin that girls use. This hairpin is having U-shaped bend. So these are known as the hairpin bend of the Himalayas. There are two hairpin bends in the Himalayas. One is this and the other is that. There are two hairpin bends in the Himalayas because of the maximum push offered by the two arms of the peninsular India, while the Himalayas are convex to the south. What do you mean by convex to the south? That means if you, as a person, you are standing here, you will see Himalayas are sagging downwards. They sag downwards, they are convex to the south. Why? Because in beach mein say there was not much pressure. So this has resulted into convex to the south. So these are known as a syntaxial bend in the Himalayas. The syntaxial bends in the Himalayas are represented by, we will do that again in the next lecture, that is in the introduction of the Himalayas, that syntaxial bend are represented by one Nanga Parbat mountain to the west and the Namcha Barwa mountain in the Arunachal China border to the east. Now, this hairpin bends are, the second point to remember about the Himalayas is they are convex to the south. And like convex to the south, therefore they are an arcuate shape. Such shape is known as an arcuate, or we can say a semicircle like shape. It is an arcuate shape. So the origin of the Himalayas, now I will rub this. The Himalayas, we can say, is an example of continent-continent collision. Continent-continent collision formed due to continent-continent collision, that is means the collision of Indian plate Indian plate with Eurasian plate, with Asian plate, with Asian plate. Now let us go this continent-continent collision. This continent-continent collision started some 50 million years ago, some 70 million years ago. So the second point is around 70 million years ago. MYA means 70 million years ago, the Indian plate started drifting towards the north, drifting towards north, or we can say towards, it started drifting to north towards Asian plate, towards the Asian plate. As it started drifting towards the north, towards the Asian plate, therefore a narrow shallow sea. Now these two plates were separated. These two plates were separated by Tethys Sea, or if the question is about the geosynclinal theory, you can substitute this Tethys Sea by and separated by a narrow shallow Tethys Sea known as a Tethys geosyncline. As the two plates came near each other, as the two plates collided, the sediments in Tethys geosyncline were folded to form Himalayas. Thus, Himalayas are young fold mountains because this occurred just some years back, some 70 million years back, and therefore these are an example of an young fold mountains. Now you remember give me a minute. The folding or the collision occurred in three phases. Occurred in three phases to give rise to three parallel ranges of Himalayas. Give rise to three parallel ranges of Himalayas. Three parallel ranges of Himalayas. So because the collision occurred in three phases, we can see there are three parallel ranges of the Himalayas. And even today, is the collision occurring or not? Even today, the Indian plate is slightly moving under the Asian plate. The process has not been completed. Even today, the Indian plate is trying to push and trying to go below the Asian plate. And whenever this Indian plate slightly moves over the Asian plate, we are living on the Indian plate or we are living on the North Plains. So if this is an Asian plate and if the Indian plate is slightly trying to push below the Asian plate, now this is a stable Indian plate. If it is, you consider this my hand as an Indian plate and this hand as an Asian plate, it is stable, but if it is trying to push slightly below the Asian plate, the plate shakes. We shake and we call it as an earthquake. So even today, you remember the Indian plate is trying to go below the Asian plate. That is why the height of the Himalayas is increasing. That is why the height of the Mount Everest is also increasing, because it is an example of an active convergent boundary. And like in any convergent boundary, there has to be earthquakes. There has to be folded mountains. But the other convergent boundaries in the world have volcanoes also. Will India have a volcano? Or does India have a volcano? Is there a volcanic eruption in Mount Everest? Is there a volcanic eruption in Vaishno Devi region? Is there a volcanic eruption in Mount Kailash region? Or is there a volcanic eruption in Northeast? The answer is no. Why it is not there? Why in all the fold mountains of the world there is a volcanic eruption except for Himalayas? Is this the reason we worship Himalayas? Because we worship Himalayas, that's why Himalayans saying, okay, I won't disturb them with the volcanic eruption. Is that the answer? No. Look here, what is an example? If you remember your plate tectonics lecture, when does the volcanic eruption occur? The volcanic eruption occurs when a dense plate, that is an oceanic plate, goes below the continental plate. When the two plates, that is the oceanic plate, if this is one oceanic plate and if this is a continental plate here, when these two plates collide, I hope that you can see this, yes. When these two plates collide, these plates, the oceanic plate being denser, the oceanic plate, that is Sima, is denser than Sial, that is the continent plate, and therefore because it is denser, it goes below inside the mantle. The oceanic plate, it goes below inside the mantle. And after going inside the mantle, yahan pe the continental plate goes upwards. The both ka sediments are folded to form the mountains here. While afterwards it goes into the mantle. Here in this part we have the oceanic trenches, your plate tectonics lecture. While after going into the mantle it gets destroyed, and because of its destruction it gets converted into what is there inside the mantle. There is large amount of heat, and therefore the oceanic plates gets destroyed, means it gets melted, and after melting the fumes rise up, vapor rises up, and then after that we have volcanic eruption. So for volcanic eruption, one plate has to be very dense, oceanic plate, and the other plate has to be lighter, that is the continental plate. When such plate combine or come together, the denser the plate, it goes deeper into the mantle. Why it goes deeper into the mantle? Because it is very dense, and isliye because density is high, it is having high weight, and the lighter the continental plates are lighter, therefore they will climb up. If something is dense and if something is light, obviously the lighter thing will float on the denser thing. So the oceanic plate being denser, it goes below inside the mantle. The continental plate being lighter, it floats upwards. After going inside the mantle, the oceanic plate is destroyed. It becomes fire, molten rock. The water vapor and the molten rock material rise up. When they rise up, they blow up the top of a mountain, and therefore there is a volcanic eruption. So whenever such two plates combine, that is the oceanic plate combine with the continental plate, there is a volcanic eruption. Now example is Rockies Mountain Pacific Plate with the North American Plate. Example is the Andes Mountain Nazca Plate with the South American Plate. Nazca Plate is an oceanic plate and the South American Plate is a continental plate. Open, that is why I am saying carry your atlas. We will revise your entire geography, that is open your plate tectonics. You open your plate tectonics page in the atlas. If you are carrying this Orient Longman atlas, if you are carrying Oxford Student Atlas, it's on the page number 114. See the Rockies Mountain of North America, Andes Mountain. It is a example of a continent and ocean collision. The same thing if you are carrying this Orient Black Swan Atlas, you will see that on the page 89, World Tectonics and Natural Hazards. This is where you will see it. So, page 114 in this atlas, page 89 in this atlas. And see here how India is. India is an example of a continent-continent collision. There was an Asian plate, it is a continental plate. Indian plate is also a largely continental plate. These two plates have come together, and because these are of the same types, the Indian plate is not going deep into the mantle. It is just lifting. If these two plates are coming, it is not going deep into the mantle, because both are having more or less the same density. I am saying more or less the same density. Indian plate is slightly denser than the Asian plate, and therefore it is going just little bit below the Asian plate, and when it is going just little bit below the Asian plate, it is lifting the Asian plate slightly higher. So instead of 30 kilometers of Earth's crust, there is a 30 plus 30, because average size of Earth's crust below the continent is 30 kilometers. Revise your first lecture of the interior of the Earth. So 30 kilometers Asian plate ka, 30 kilometers Indian plate ka, it is not going deep inside the mantle and getting destroyed because it is also a continental plate. So you can see in the diagram, it is going just below the Asian plate. That means in my hand, this diagram, the third figure in my hand will be, these two plates are coming and Indian plate is just going below the Asian plate. So the depth of a crust becomes the thickness of the crust becomes very high. That is the high mountain system. Yahan pe the thickness of the crust is very high. And because the thickness of the crust is very high, in Himalayas, we have a phenomenon of doubling up of the Earth's crust. Asian plate ka crust, Indian plate ka crust, and then sediments ka crust. So there is a phenomenon of a doubling up of the Earth's crust. There is a phenomenon of a doubling up of the Earth's crust. That means the thickness of the crust is very high. That is somewhere around 75 kilometers, and therefore the thickness of the crust is very high. The first thing is Indian plate is not going inside and getting destroyed. Even if there is a volcanic eruption, because of the thickness of the crust is so high, the volcanoes cannot remove such greater depth. They cannot remove the crust which is thick, which is 75 kilometers thick, and therefore Himalayas do not have volcanic eruption. Why? Because of the doubling up of the crust. Why? Because the thickness of the crust is very high. But the basic reason is why there is a doubling up of the Earth's crust, or the basic reason is why the thickness of the Earth's crust is very high. Because Himalayan mountains are an example of an continent-continent collision. Is an example of an continent-continent collision, and because these are the examples of a continent-continent collision, therefore there is an absence absence of volcanic eruptions in the Himalayas. And therefore, because it is an example of a doubling up of the earth's crust, when there is a continent-continent collision, continent and continent collision, this both are coming together, and this Indian plate is slightly lifting the Eurasian plate upwards. This combination area of this duster and this specs box is what is the Himalayan region. This is what you can see is the doubling up of the earth's crust, and therefore iska application is this doubling. Wherever the doubling of the earth's crust has happened, the height of the earth's crust is very large, and therefore the second reason, because it is an example of a continent-continent collision, therefore there is an absence of volcanoes in the Himalayas, and also therefore the Himalayas have such a great height. That is, the Himalayas are the highest mountain systems in the world. Now, if you ask me that initially was there a volcano in Himalayas? If you ask me this, you just have to repeat, you just have to imagine what we have drawn previously. What we drew previously, there was a Tethys Sea in between. Initially, obviously, the Tethys Sea went below. Tethys Sea was an ocean, and the ocean went below. And therefore, obviously, jahan ocean will go below, because the oceanic part is dense, Sima. Continental part is light, Sial. As the Sima is denser than Sial, when during the previous some million years ago, when initially the great ranges of the Himalayas were formed, that is, when the Tethys Sea went below, obviously that time, during that some million years ago, there was volcanic eruption in the Himalayas. Why? Because initially the Tethys Sea went below, and then the Indian plate collided, and then the sediments from the Indian plate, Tethys Sea and the Himalayas collided to form, and the Asian plate collided to form the Himalayas. So obviously, jahan pe I am showing this is a mixture of blue, red, black, because this two ranges of the Himalayas have all the sediments of the Indian plate as well as the Tethys Sea. But the innermost Himalayas, that is the Great Himalayas, when they were formed only during the collision of the Tethys Sea and the Eurasian plate. Why? Because as the Indian plate was coming towards the Eurasian plate, Indian plate, as they were coming, the sediments of the Tethys Sea got folded, and when the Tethys Sea got folded, we had volcanic eruption. So there is an evidence of volcanic eruption in the Kargil and Dras region of Himalayas, but that was many years ago. As of today, Himalayas do not have any volcanoes. Not extinct volcanoes, neither dormant volcanoes. Evidences are there in the Kargil and Dras region. For you general studies point of view, you remember Himalayas as such today do not have a volcanic eruption, because they are example of a continent-continent collision. Because it is an example of a continent-continent collision, there is a phenomena which is known as a doubling up of the earth's crust. And because of the doubling up of the earth's crust, Himalayas have a greater height. So this is all about the origin of the Himalayas. So I will repeat again, we will revise what we studied in this lecture. Himalayas were formed due to collision of Indian plate with the Eurasian plate. Second point, both of them were the continental plates. Third point, they were separated by a narrow shallow sea known as Tethys Sea or the Tethys geosyncline. Fourth point, as the Indian plate came towards the Eurasian plate, the sediments in the Tethys Sea got compressed, got squeezed, got folded. Fifth point, when the Indian plate collided with the Asian plate, the sediments from the Tethys Sea, from the Indian and Asian plate were folded to form the Himalayan ranges. Sixth point, as the collision occurred in three different phases, therefore we have three parallel ranges of the Himalayas. Thus, we can conclude that the Himalayas came out of a Tethys geosyncline due to continent-continent collision. Seventh point, as it is an example of a continent-continent collision, therefore none of the plate is subducted into the mantle and destroyed. but the Indian plate being slightly denser than the Eurasian plate, it goes slightly below the Asian plate. You can write either Eurasian also, you can write about the Asian also. It goes slightly below the Asian plate. 8th point, and therefore, as it is an example of a continent-continent collision, there is an absence of volcanoes in the Himalayas. 9th point, since there is a doubling up of the Earth's crust, the Himalayas have greatest height. Therefore, the Himalayas are the highest mountain system in the world, and therefore, the plateau region even in the Himalayas, that is this flat region which did not got compressed, is the highest plateau in the world, is the Tibetan plateau region or the Leh Ladakh plateau region. So therefore, we have the greater Himalayas, the middle Himalayas and the Shivalik ranges which are formed, and in between this gap, which is here, you can see in between this gap here got filled up by the sediments to form the Great Plains of India. So we have this Leh Ladakh plateau region. Again I will repeat, we have Leh Ladakh plateau, we have the Great Himalayas, we have Middle Himalayas, we have Shivalik ranges, we have the Great Plains of India, and we have the Peninsular Plateau region of India. So this is how the India looks like. Leh Ladakh plateau, Greater Himalayas. What are these Greater Himalayas? We will do in the next lecture. Middle Himalayas, Shivalik ranges, in between jahan pe the Indian plate goes slightly below the Eurasian plate, there is a subduction zone, there is a depression which has now been filled up by the rivers which originate from the Himalayas and come to this downwards. They have brought large amount of mud, they have brought large amount of broken stones and filled up this gap, which is known as the Great Plains of India, and after that we have the Peninsular Plateau region. So this is how the Indian plate is. I hope that you have understood. Remember from the exam point of view, remember from the prelims point of view, Himalayas came out of a Tethys geosyncline, and Himalayas are an example of a continent-continent collision. Therefore, greater height of the Himalayas and therefore absence of volcanoes in the Himalayas. Otherwise, in all other young fold mountains, which I say are the cousins of the Himalayas, that is the Rockies, that is the Andes, that is the Alps, we have volcanoes, but not in Himalayas, because this only is an example of an continent-continent collision. We will continue with the division of the Himalayas, and I hope that you will enjoy the Indian geography. So meet you soon in the next lecture. Till that time, thank you very much.